Welcome to The Explainer. Today, we're diving into a huge milestone in India's incredibly ambitious plan for its energy future, a nuclear program that's all about building a bridge to, well, basically unlimited power. So, just recently on April 6th, after literally decades of work, a brand new, revolutionary kind of nuclear reactor in India finally came to life. It hit a major milestone called criticality. But what on earth does that actually mean? So, what is criticality, really? And why is this just the very beginning of a much, much longer journey? Let's break it all down. Okay, first things first. When you hear that a nuclear reactor has achieved criticality, it sounds, well, critical, right? It sounds like the grand finale. But in the world of nuclear power, it's actually the exact opposite. Think of it as the starting line of a marathon, not the finish. Criticality is that precise, perfect moment when the nuclear chain reaction inside the reactor can finally sustain itself. It's exactly like turning the key in your car's ignition. The engine is on, it's running smoothly all by itself, and it's in a stable, controlled state. It's ready to go. But, and this is a huge but, just because the engine is on, it doesn't mean the car is moving. This reactor isn't powering a single light bulb or factory yet. Actually generating electricity for the grid, that's a whole other step that's still a good ways down the road. Which, brings up a pretty big question. Why would you spend over 20 years building such a complicated and expensive reactor just to get to step one? To get that, we've got to zoom out and look at India's epic long-term nuclear strategy. You see, from the very beginning, India has had this unique energy puzzle to solve. The country is sitting on one of the world's biggest stockpiles of thorium, which is a potential nuclear fuel, but it has very, very little of the traditional uranium that most reactors use. This imbalance led a physicist named Homi Bhabha to come up with a really clever three-stage plan for total energy independence. And here's how the plan works. Stage 1, you use your limited uranium in conventional reactors to make electricity, and you get a critical byproduct, plutonium. Stage 2, and this is where our new reactor comes in. You take that plutonium and use it in these advanced fast breeder reactors to make more power and to breed even more fuel. And all of that work paves the way for Stage 3, where future reactors can finally tap into India's gigantic thorium reserves, unlocking a nearly endless supply of domestic energy. And that is why this new reactor is such a big deal. The Fast Breeder Reactor, or FBR, isn't just another power plant. It's the critical link. It's the indispensable bridge that connects India's energy situation today to its goal of an energy-independent future. So, how does this incredible technological bridge actually work? What makes a fast breeder reactor so different from the ones we're used to? Well, the difference is pretty stark. A standard reactor uses slow neutrons, and it's only about 1% efficient. But an FBR uses fast neutrons, and that dramatically boosts its efficiency. But here's the absolute game changer. An FBR is designed to make power and create more fuel than it burns. Yeah, you heard that right. It's a reactor that breathes. It's basically the ultimate nuclear recycling system. It can take material from older reactors that would normally be considered waste, and through nuclear transmutation, it turns that waste into brand new plutonium fuel. It's a stunningly efficient process. Okay, so if this technology is so revolutionary, why has it taken so long? Why have other major countries struggled with it or just given up entirely? Well, it's because this bridge is both dangerous and incredibly expensive to build. And the number one challenge really comes down to the coolant. Instead of water, FBRs use liquid sodium. Now, it's fantastic at transferring heat, which is great, but it has a massive, massive downside. It explodes if it comes into contact with air or water. That means every single pipe, every seal has to be absolutely perfect, which makes things way more complex and way more expensive. And listen, these aren't just theoretical problems. Back in 1995, Japan's Manju breeder reactor had a major sodium leak and a fire that ended up killing the project. France's Super Phoenix reactor, the biggest FBR ever built, was also shut down because of technical problems and just astronomical costs. Today, Russia is basically the only country that still operates a small number of these commercially. So it's pretty clear the challenge here isn't just about the engineering. It's also a serious question of whether the technology can ever be economically viable and politically sustainable. And that economic struggle is very, very real. India's prototype reactor was originally supposed to cost about 3,500 crore rupees. By 2019, that cost had almost doubled to 6,800 crore. Now, part of this is because of the unique way India's nuclear program is structured. It's run by the state and reports right to the Prime Minister's office. On one hand, that insulates it from short-term politics, which is good for a long project. But the flip side is there's less public oversight when budgets get blown and timelines slip.
So, they've achieved criticality. The engine is on. What's the plan now? What are the next steps on this long road from an amazing experiment to an actual working power plant?
It's a slow, careful, and painstaking process. First, they'll run the reactor at very low power for months, just collecting tons and tons of data to make sure everything works exactly as it's supposed to. Then they use all that data to fine-tune the safety rules before they can get final approval from the regulators. Only after all that will they slowly start to ramp up the power and connect to the grid.
And you have to remember, the reactor itself is only one piece of the puzzle. To make the whole fuel cycle work, an entire new industrial infrastructure for reprocessing the spent fuel also has to be designed, built, and perfected. It's a massive undertaking. So, after decades of work, after immense cost, and after overcoming some really daunting technical challenges, India's nuclear bridge is finally taking shape. Which leaves us with the ultimate question. Is this bridge strong enough to carry the full weight of a nation's energy future?